Okay class, my name is Rex Estrada Obida, your instructor for today. So before we're going to start our class, may I ask everyone to please bow down their heads for the prayer, and the classroom mayor please lead the prayer. Amen. Okay class, good morning. So may I request everyone to please open their camera for the attendance. Okay class, how was your day? Good. So please spam one if you have a strong connection, and spam two if you don't have if you have a poor connection. So I guess all of you spam one, so you have a strong connection. So let's proceed with the discussion. So today we're going to discuss about the power rule for integration. So before that, let me present first to you the objectives for today. So at the end of the lesson, the students are able to define power rule for integrations. Second, integrate any functions that can be written as power of x. Third, enumerate the steps in solving the power rule for integration. Okay class, I want you to prepare yourselves for an activity before we're going to start our proper discussion. So this activity is what we call powered. So the mechanics of the game, you will be given number according to its power, and they're going to give its power within 1 minute in every number. So after answering, you directly PM it to me for me to check it. Okay class. So this will be your activity class. So time's up. Can you PM to me the answers of the activity? Alright class, let's have a quick review. So what have you understand about the previous meeting? Yes? Okay, thank you for that idea. Another? Very good. So today we're going to discuss about the power rule for integration. So what is power rule for integration? So what is power rule for integration? So the power rule for integration is an important and fundamental in the integral calculus. The inverser process of differentiation is called integration. The power rule for integration provides us a formula that will allow us to integrate any function that can be written as power of x. So in solving power rule for integration, we can use this formula. Okay, here are the examples of power rule for integrations. So in example 1, you can show every step-by-step process upon the solving the equation. So in every equation, there are steps of solving for you to get the exact final answers. So in every example, we need to simplify it simple. So example, we have the equation 2x cubed dx. So our given for the a is 2, and the given of the n is 3. So in this equation, we need to copy the equation 2x cubed dx equals 2 over 3 plus 1 times x cubed plus 1 plus c. So to simplify this equation, we need to have equals 2 over 4 x to the power of 4 plus c. So simplify that equation, so we have 1 half x to the power of 4 plus c. So that will be the answer of that equation. So another example, we have the equation of 4x raised to the power of 5th dx. So our given for a is equals to 4, and our given for n is equals to 5. So in this equation, we need to copy the 4x raised to the power of 5 dx. equals to 4 over 5 plus 1 times x raised to the power of 5 plus 1 plus c. So to simplify that equation, we need to have 4 over 6, we have times 6 to the power of 6 plus c. So to simplify this equation, we have 2/3 x raised to the power of 6 plus c. So in this equation, that 4x to the power of 5 dx, we have the final answer of 2/3 x raised to the power of 6 plus c. So another example, we have this given that 5 over x raised to the power of 4 dx. So to copy the equation, we have 5 over x to the power of 4 dx equal 5x raised to the power of minus 4 dx. To simplify that, we have 5 over negative 4 plus 1 x raised to the power of 4 plus 1 plus c. So to simplify that equation, we have 5 over negative 3 x raised to the power of negative 3 plus c. So to simplify this equation, we have the simplification answer that 5 over negative 3 times 1 over x cubed plus c. So another example, we have this given that 2 times to the square root 3 square root x dx equals 2 times x raised to the power of 1 over 3 dx. So to simplify that equation, we have 2 over 1/3 plus 3 times x raised to the power of 1/3 times plus 1 plus c. To simplify that equation, we have 2 over 4/3 x raised to the power of 4/3 plus c. And then the equation we have, so we have the equation of 2 times 3 square root of x raised to the power of 4 plus c.
To some power, remember that the power comes out and multiplies in the front, and then we decrease the power by 1. We subtract 1 from the exponent. So our power rule for integration, if we were going to take the antiderivative of x to some power as the function, then that's simply going to be the opposite process in the opposite order. So here we multiplied in the front and then subtracted in the exponent. So going in the opposite order, we would affect the exponent first, and then what comes out second. So the opposite of subtracting 1 from the exponent is going to be adding 1 to the exponent. So our power will go up by 1. And then instead of multiplying out front, we're going to actually divide. So we will divide by our new power, n plus 1. So our antiderivative formula for x to the n dx is x to the n plus 1 divided by n plus 1. And we always want to remember to include our constant of integration. Let's take a look at some examples here. So we have the integral of x cubed dx. So the first thing I will do is add 1 to my power. We'll say x to the 4. And then I will divide by my new power, so we'll get over 4 plus c. We could go ahead and, if you prefer, you would like to say 1/4 instead of over 4, x to the 4 plus c. Either of those are a good answer. Looking down here, the integral of x to the 5 dx, so our power goes up by 1, we get x to the 6, divided by the new power, which is 6, plus our constant of integration. Or if you prefer, you can certainly say 1/6 x to the 6 plus c. Either of those are fine. Up here, the next one, the antiderivative of square root x dx. So remember, when we did derivatives of square root, we could also think of those as a power rule. Square root x, remember, is x to the 1/2 power. So we're actually taking the antiderivative of x to the 1/2, and the power rule says we would add 1 to this. 1/2 plus 1 is 1.5, also known as 3/2. So we get the 3/2 power of x. Now we'll divide by that new power, right? So divide by 3/2 plus our constant of integration. And we don't want to leave this one with a fraction in a fraction. So we'll go ahead and, instead of divide by 3/2, let's bump that out and call it multiply by the reciprocal instead. So we'll say 2/3 x to the 3/2 plus our constant of integration there. And looking at this next one here, the antiderivative of the cube root of x dx. So just remember that this index of 3 for the cube root makes this the 1/3 power. So we can treat the integral of cube root x as integral x to the 1/3 dx. We will still do our power rule of raising the power by 1. 1/3 plus 1 gives us 1 1/3, also known as 4/3. So we get the 4/3 power of x. We'll then divide by our power of 4/3. So we'll get x to the 4/3 divided by 4/3 plus c. And cleaning that up so we don't have a fraction and a fraction, again, we'll go ahead and bump that up and multiply by the reciprocal. So we'll actually get an answer of 3/4 x to the 4/3 plus our constant. If the power had gone down by 1 to give us 3 here, then increasing the power of x by 1 would actually make 3x for us. Now we'll need 3x plus our constant, right, of integration to actually give us a derivative of 3 there. So in a way you can imagine a term like x to the 0 after this 3, and the power goes up by 1. Dividing by 1 won't change anything here. Now the integral of 0 is a bit different. These are both constants, but to get a derivative of 3 that is not 0, I need to have some term that is not just a constant, right? This 3x is what gives me the derivative of 3. But here when I say the antiderivative of 0 dx, that means we have some function that gives us a derivative of 0. And we know what gives us a derivative of 0, I think. Those are just constants. So this answer here is just going to be c. The derivative of a constant is 0, so the antiderivative of 0 is a constant. Looking over here, we have the integral of 1 over x squared dx, so we can think of this as a power rule as well. This is really like x to the negative 2 dx, so the power rule applies here. We can add 1 to the power, becomes x to the negative 1. Dividing by that new power gives us divide by negative 1 plus c, and then we should go ahead and clean this up and just say negative out front instead of divide by negative 1. And x to the minus 1 is really just the reciprocal of x, so that's x to the negative 1 written as a fraction. Plus c, oftentimes we don't want negative powers written in our answers, so this is usually going to be the preferred way to write x to the minus 1 over negative 1. Looking at this next one here, we have the integral of 1 over x to the 4 dx, so we just see this as a reciprocal again. This is really the antiderivative x to the negative 4 dx. So our power will go up by 1, so we'll have x to the negative 3. We'll divide by that new power of negative 3, plus our constant of integration. And now here, this negative 3 in the bottom is like negative 1/3, so we have negative 1/3, but where is our x to the negative 3, right? That's actually an x cubed in the denominator, right? So that actually says put the x cubed down there with the 3 plus our constant. Let's look at just 2 more here. So we have the integral of 1 over square root x dx. So a couple of things. We know that this is reciprocal, and it's also the 1/2 power in the root. So this is really saying the antiderivative of x to the negative 1/2 dx. So if we do the power rule here, we'll add 1 to negative 1/2, which gives us positive 1/2. Dividing by that new power of positive 1/2, we'll want to change that, right? Plus c. So we've got divide by 1/2. Let's bump that out and multiply by the reciprocal instead. That would become times 2 on the outside. And our x to the 1/2, remember another way to write that would just be to say square root x. So we could say 2 root x plus c for this example. For this final one in our video here, we have the antiderivative of 1 over x dx. This one's a little bit strange. If I try to use the power rule with this, I would say, well, that's like x to the negative 1 power dx. But the problem with trying to use the power rule on this one is that we get what? We get x to the 0, which we might be able to figure out, but then divide by what? Well, divide by 0, and that's undefined, right? So that doesn't make any sense. So the way we actually see this is we have to think about, do we know, outside of the power rule, some function that gives us a derivative of 1 over x? And the answer is, it's actually the natural log function. So this one here looks like a power rule, but it's one that's not a power rule. So this antiderivative is actually ln of x plus c. And a small extra thing here, the domains of these functions are not actually the same, so we actually include an absolute value on our ln of x when you do the antiderivative. The reason that absolute value only happens one direction, all of the domain of natural log is in the domain of 1 over x, but not all of the domain of 1 over x is in the domain of natural log, so this absolute value only happens one direction. But this is not a power rule, which brings us to the next video in our series, which is about doing antiderivatives using reverse derivative rules. Thanks for watching, everybody. We'll see you then.
That's right, finding out how to integrate, finding the antiderivative. So that's what the focus of this video is going to be about. So first, let's look at what the power rule is. Here we have the integral of u to the n du, which would be equivalent to u to the n plus 1 divided by n plus 1 plus your constant of integration. So what does all that mean to you? Either you have a variable or a function, let's say of x, raised to a power with respect to that variable, all right? And then to integrate that, you would take that variable or function and add 1 to its exponent divided by that same value. Then you'll add your constant of integration with the condition that n cannot equal to -1, which means that you can't use this rule if the exponent equals to -1. In other words, you'll have to use another method in order to integrate that type of problem. So we're going to focus on problems that will use this rule, so that's what we'll look at today. Let's go ahead and take a look at them. In problem number 1, we have the integral of 4x plus 3 with respect to x. So that's what dx means. That means that this derivative that you're trying to find the original function for was derived with respect to x. You need to know the variable that they derived the original function with in order to generate the original expression. In other words, they're giving you the derivative and you're going back in time. You're going to reverse the operation in order to find out what the original function was. So my first step here is to recognize that we have two terms within the parentheses here. And using integration rules, we can separate this into two separate integral problems. So I'm going to start out by rewriting this as the integral of 4x dx plus the integral of 3 dx. All right, so like that. So I'm separating the problem. And notice that I'm keeping that dx to let the reader know I'm still doing this with respect to x. All right. The next step is to factor out the coefficient in each integrand. So what I'm going to do is I'm going to rewrite this as 4 times the integral of x dx plus 3 times the integral of 1 dx. All right. At this point,
since there are 25 students present in this class, so I want you to group yourselves into 5. So in every group there are 5 members. So I am going to present a topic and then you're going to answer it in a group. So in a group there will be 1 representatives to directly PM to me the answers in order for me to check it. So the score of the leader will be the score of the members. So you need to solve it properly and you need to help each one another for you to have a good score. Solve this equation and perform these activities. Okay class, so what have you learned about power rule for integration? Okay, yes. Thank you. Another? Alright, so can anyone enumerate the steps in solving the power rule for integration? Yes? Very good. So, since you already knew really about the topic, so here are an activity for you to answer. So this activity will be individual. So I am going to present the activity. So every one of you must solve it and answer it on a sheet of paper, and then and directly PM it to me. So for your assignments, I want you to research about the odd and even of sine power of x. Okay class, that would be the end of our discussion. So I hope you learned something from it. So that would be all. Once again, I am Rex Estrada Obida, your instructor for today's lesson.